Good day, learners! This is Teacher Corley, and today we're going to discuss about linear equation involving one variable. This time, we are going to solve linear equations in one variable. If we are asked to solve an equation, we are actually looking for the value of the variable that would satisfy the equation or that would make the equation true. Now we are going to solve one-step linear equations. What do you mean by this? These are equations which involve only one operation, whether it's addition, subtraction, multiplication, or division. And whatever operation is involved, we are going to make use of its inverse operation. So whether if it is addition, then we will do subtraction. If it is multiplication, then we will do division, and vice versa. Take a look at example number 1. We have here x plus 5 is equal to 8. Again, this is a linear equation because it involves an equal symbol and a variable whose exponent is 1. So here, when we are asked to solve for a linear equation, we are actually looking for the value of x that would make the equation true. I know you already have an answer in mind, and I know that is right. Very good. But let us solve this algebraically. As what I have said a while ago, we are going to apply the inverse operation. So the first step here is to isolate x and combine all constants at the other side. So to isolate x, or to eliminate 5 here, since 5 is added to x, we are going to subtract 5 on both sides of the equation. Again, since you have plus 5, then we will do minus 5 to both sides of the equation. So you have here x plus 5 minus 5 is equal to 8 minus 5. As you can see, we subtracted 5 on both sides of the equation. Always remember, whatever you do at the right-hand side, that is what you're going to do also at the left-hand side. So, x plus 5 minus 5, 5 minus 5 here is 0, so what is left is just x, equals 8 minus 5 is 3. I know you already had 3 in mind, and that is really correct. Okay? So, x here is equal to 3, which makes this x plus 5 equals 8 a true equation. So, when we do checking, so we have here checking. Okay? X plus 5, is it really equal to 8? Question mark. X is 3 here. 3 plus 5, is it really equal to 8? 3 plus 5 is 8, which is actually equal to 8. So, therefore, it is a true statement. Therefore, 3 is the correct answer for the value of x. This time, we are given another example, which is a minus 1 is equal to 5. And you are asked to solve this equation. Again, when you are asked to solve an equation, you are actually looking for the value of the variable that would make the equation true. This time, our variable is a. So, here, you have a minus 1 equals 5. I intentionally leave a space on both sides of the equation because we are going to do the inverse of the given equation. So, since negative 1 is added to a, or 1 is subtracted from a, we are going to add 1 on both sides of the equation. Again, since this is minus 1, we are going to add 1. Not only on one side, but also on the other side of the equation. What is our goal here? Our goal here is to isolate A or to leave only A at one side of the equation. So, negative 1 plus 1 is 0. What is left is just A. Equals 5 plus 1 is 6. So here what we used is the addition property of equality. We added because that is an inverse of subtraction. Okay? Now, A here is equal to 6. When we do the checking, is 6 really the value of A? Is 6 really would make this equation true? So, the original equation is A minus 1 is equal to 5. A here is 6 minus 1. Is it really equal to 5? So, 6 minus 1 is 5, which is really equal to 5. Since both sides of the equation are equal, we can say that 6 is the value of A that would make A minus 1 equals 5 a true statement. This time, we have another example that involves multiplication. So, for example, you have 3x is equal to 15. Since 3 is beside a variable x, it means that 3 is multiplied to x, or 3 times x is equal to 15. Okay? 3x here is not 3 plus x, but 3 times x. Okay? The operation involved here is multiplication. So as what I have said, we will do the inverse. And we are going to do it on both sides of the equation, not just on one side. Now, since 3 times x equals 5, we are going to divide both sides by the coefficient of x. Again, our goal is to find only the value of x. So, 3x is equal to 15. We are going to divide both sides by 3. Or whatever is the coefficient of the variable. If the coefficient of the variable is 5, then we are going to divide both sides by 5. But since the coefficient of x here is 3, then we are going to divide both sides by 3. 3 divided by 3 is 1. That's why we canceled it. So, what is left is just x. So, it is 1x only because we are going to find the value of x. Then 15 divided by 3 is 5. So x is equal to 5. If we are going to do the checking, okay, always check. 3 times x or 3x is equal to 15. And the value of x is 5. So 3 times 5, is it really equal to 15? 3 times 5 is 15, which is really equal to 15. Since both sides of the equation are equal, we can now say that 5 is the value of x here that would make 3x equals 15 a true statement. So what if division is involved? So, for example, you have x over 8 is equal to 2. What should be the value of x when it is divided by 8? The answer is 2. I know you already have an answer in mind. I know you are really very smart. But this time we are going to solve it algebraically. Again, the operation involved is division. So we are going to do the reverse. The inverse of division is multiplication. So x over 8 equals 2. Then we are going to multiply both sides by 8. not just on one side, but both sides. Okay? Since the operation involved is division, then we are going to do the inverse operation to both sides of the equation. That's why we multiply both sides by 8. So 8 divided by 8 is 1. So what is left is just x. 2 times 8 is 16. Is 16 really the value of x here? So let us do the checking. Anyway, you can check it mentally anyway. So like 16 divided by 8 is equal to 2. But if we are going to show it, x over 8 equals 2, which is the original equation, then the value of x here is 16 over 8. Is it really equal to 2? So 16 divided by 8 is 2, which is actually equal to 2. Okay? So it is actually equal to 2. It results to a true statement. Therefore, x is equal to 16. And 16 makes this equation a true statement.